Okay, let's get right into it. Lecture 11. We are tackling hypersensitivity and allergy.
Mm-hmm.
And looking at the notes here, the stakes feel pretty high. This is marked up as a critical exam topic.
It absolutely is. I mean, if you're using this to prep, this is a real cornerstone concept.
Right.
We have to understand how the immune system, your biological bodyguard, basically goes rogue.
It's like friendly fire, but on a cellular level.
Exactly. But it's not random, and this is the core rule.
Right.
The system has to be primed first. You need that prior sensitization.
So you can't be hypersensitive to something you've never met before.
Precisely. You need that first exposure where the immune system sees the antigen and memorizes it. The hypersensitivity is the crazy, over-the-top reaction on the second exposure.
Okay, so for the exam, how do we keep this organized?
It's all about the mechanism, not the symptoms. We have 4 types based strictly on the immunology.
Let's break them down then. Type I.
Yeah.
This is what most people just call an allergy, right?
Yeah.
Immediate hypersensitivity.
That's the one. And the main character here, the one you have to remember, is the IgE antibody.
So walk me through it. I inhale some pollen for the first time. What's actually happened?
The first time, you won't feel a thing. Your Th2 helper cells will activate your B cells, telling them, hey, make IgE for this.
Okay.
Those IgE antibodies then go and plant themselves on the surface of your mast cells.
So the mast cell is now armed. It's a loaded gun just waiting.
That's the sensitization phase, exactly. So the next time you inhale that same pollen, the allergen cross-links those IgE antibodies,
Right.
and boom, degranulation. The mast cell just dumps its entire payload of histamine and other mediators.
Which explains why they call it immediate.
Mm.
The weapons are already made. They just need the order to fire. We're talking minutes, right?
Minutes. But don't forget the late phase. This is key for the exam. Hours later, you get a second wave of inflammation that can cause more lasting tissue damage.
So that's why an asthma attack isn't just a quick thing.
Right. And in the absolute worst case scenario, you get anaphylaxis. The whole system goes into shock. Your blood pressure just tanks.
Which is where epinephrine comes in to basically reverse the physics of the reaction.
It constricts the vessels, opens the airways. A direct countermeasure.
Okay, let's switch gears. Type 2, antibody-mediated. Still antibodies, but a different job.
Yep. Now we're talking about IgG or IgM. And the crucial difference is the target. In type 1, the allergen is floating free. In type 2, the antibody attacks an antigen that is fixed to a cell surface.
So it's more personal. It's going after that specific cell.
And it has a few ways to destroy it. It can trigger inflammation, or it can tag the cell for phagocytosis, basically putting a kick-me sign on it for macrophages.
You said a few ways. What's the third one?
This one is tricky and good to know for the test. Sometimes it doesn't kill the cell, it just hacks its function.
What do you mean hacks?
In Graves' disease, an antibody binds the thyroid receptor and just holds down the on button. You get hyperthyroidism, but no actual cell death.
Functional chaos.
Or myasthenia gravis, where it blocks muscle receptors. But for a classic cell-killing example, think of a bad blood transfusion.
Giving type A blood to a type B patient.
You got it. The recipient's antibodies immediately attack and destroy those donor red blood cells. That's a classic type 2 cytotoxic response.
Got it. Okay, type 3. Immune complex mediated. I always think of this one as a plumbing issue.
That's a perfect analogy. Here, the antigen and antibody bind together while they're floating in the circulation. They form these little insoluble clumps.
And like gunk in a pipe, they get stuck somewhere.
Usually in high-pressure filters, like the kidneys. Once they get deposited in the vessel walls, they trigger complement. Neutrophils show up to clean up the mess and just end up damaging the surrounding tissue.
So the damage is collateral. The kidney wasn't the target. It was just where the fight went down.
Precisely.
And finally, type 4, the odd one out.
The delayed type. It's the only one that is not mediated by antibodies. This is all T cells.
Which explains why it's delayed. Mobilizing an army of T cells takes more time than just releasing pre-made antibodies.
Right. We're talking 24, maybe 48 hours. The classic example is like a nickel allergy from a cheap watch.
You wear it on Monday, but the rash doesn't show up until Wednesday.
Because it takes that long for T cells to get to the skin and call in the macrophages to cause that inflammation.
Okay, so a quick recap for anyone studying. The cheat sheet would be type I.
IgE and mast cells, immediate.
Type 2.
IgG or IgM attacking a fixed cell surface.
Type 3.
Floating immune complex is getting stuck. Plumbing problem.
And type 4.
P cells only. No antibodies. And it's delayed.
It's just wild. You break it down, these are all the immune system's normal tools,
Hmm.
inflammation, T cells, antibodies, just being used too aggressively or against the wrong thing.
It really is. It frames the central paradox of immunology. We have this system that's powerful enough to kill cancer and fight off deadly microbes. So you have to wonder, is it even possible to have a weapon that potent without the risk of it, occasionally blowing up in our own faces?
A pretty sobering thought to end on. Thanks for the deep dive.